This is our last video for the week, and so we're going to be discussing emotion. And so emotion and motivation go hand in hand. Any given moment, you are experiencing some sort of emotion, although you might not realize it. But emotion too is a motivator, right? So for instance, whenever you're fearful of something, that might encourage you to avoid that and to retreat. Whenever you are fond of something, whenever you feel happy and elated, that encourages kind of like this approach behavior, right? So that's a real kind of simple dichotomy, but ultimately you're feeling emotions at any given moment, and that's influencing, um, how you think, but also how you behave, right? And how you engage in goal motivated behaviors. So to begin, I want to quote William James. We talked about William James in chapter 1. He was a functionalist and one of the most important psychologists of all time. And he did such an awesome job of describing the importance of emotion. So he said, if you can conceive of yourself suddenly stripped of all the emotion with which our world now inspires you, no one portion of the universe would then have importance beyond another, and the whole character of its things and series of its events would be without significance, character, expression, or perspective. And that was just such an eloquent way of saying that emotion is really, really important and it colors our life, right? So without emotion, you would be completely indifferent to everyone and everything. No one thing would hold greater importance than another. You wouldn't have preferences, you wouldn't have taste, you wouldn't have likes or anything like that. Your world would be colorless, right? And so emotion is so very important, is always running in the background, despite the fact that you might not be cognizant of it, but nevertheless, it has a very powerful influence on our behavior. So let's talk about emotion. Um, so emotion, basically with emotion comes changes in the body. It can involve changes in behavior and can involve changes in consciousness. So what's being held in mind at a current moment. In addition, emotion is rooted in evolution. And so it serves this basic survival function, and it was very important to our ancestors. I described the avoid approach behaviors before. For instance, imagine living in a world without fear. While at first that might seem very desirable, you would probably get yourself in a lot of bad situations. And in fact, we'll talk about someone who basically never experienced fear before. So that will be an interesting discussion we'll have here in a little bit. So with emotion, emotions are a mix of bodily arousal, so things that are happening internally, talking about physiology. So for instance, heart pounding, right? We talked about this dynamic relationship between the sympathetic and parasympathetic nervous systems, right? Behaviors, right? So expressing behaviors. So for instance, if someone, God forbid, is following you and they're suspicious, right? That might result in a quicker pace or something like that, right? So it could involve a change in behavior as well. And then finally, conscious experience, right? So basically what we're talking about there are cognitions, right? So thoughts, that are being held in short-term memory so that you can process it. So one raging debate that has occurred in psychology, and it happened for quite some time, so for decades, and this argument dates back over a century ago, is the question of, is there kind of like a temporal order in which these different aspects of emotion are experienced, or are they experienced at the same time? So let's consider two competing theories. On the left, we have what's known as the James Lange theory, James referring to William James, Lange referring to a later researcher, but they together basically make up this James Lange theory. So according to this theory, there is kind of this temporal order. So let's say that you're walking in the woods and you see this giant ass bear, okay? So the stimulus is perceived. According to the James Lange theory, you have this emotional expression and physiological response But importantly, that occurs before you have the emotional experience. So in other words, that conscious recognition and appraisal of the situation. So in other words, you come across this bear. According to James Lang theory, what first happens is that your heart probably quickens. You might even turn to start running. You might have a fear, like a face that is fearful, right? And according to this theory, this all happens before you are actually consciously cognizant of what's happening, right? So you're understanding what's happening. So it's only to where you turn and you start running to where you realize, oh wow, that was a bear. I should continue running, right? So that's the James Lang theory. According to the Cannon-Bard theory, okay, this is a competing theory. What it argues is that these two processes happen at the same time. So you see a bear, you have this emotional expression and physiological response, but also at the same time, you are consciously aware of this fearful stimulus. And all this happens instantaneously and simultaneously, okay? So there's been debate back and forth about which one appears to be correct or more correct. And what it seems is that the James Lang theory does have kind of an edge. So for instance, in a study of individuals who have a high spinal cord injury, they have this kind of blunted experience of anger. And so what this is suggesting is that there's kind of this like interconnectedness between the physiology and the actual conscious experience. So in other words, those who might have impairment in movement and things like that, they might experience emotions to a lesser extent, which is super interesting. So next I want to move on to another theory of emotion. It's a little bit different from those first two theories, but it's still pretty interesting. It's known as the Schachter-Singer theory of emotion. And so what it argues is that emotions require the cognitive labeling of a physiological response. Okay. So consider this following scenario. You have the stimulus, which is a growling dog. This results in a change in physiology. But according to the Schachter-Singer theory, what is important here is this cognitive labeling. So it's almost like this internal appraisal of one's own physiology and trying to figure out what's happening. So your brain's basically playing detective, why is my heart racing? Why is this happening? And then eventually what happens is the end result is this experience of fear. So again, according to the Schachter-Singer theory, the important part here is this third part here, this cognitive labeling, right? Because keep in mind that our experience of some emotions, physiologically speaking, can be very much the same, right? So like, for instance, like fear and anger, physiologically speaking, might produce kind of similar changes in the body. So again, increased heart rate, increased breathing, sweating, so on and so forth. So just increased sympathetic nervous system activity. So it's not the physiology alone, it's more the cognitive labeling. So your brain playing detective and figuring out, why am I feeling the way that I'm feeling? Schachter and Singer, they did a really interesting study back in 1962. And so what they did was that they had participants divided into two groups. They had what was known as an adrenaline group and a saline group. So saline referring to just like a salt solution. That was basically a control. So participants in the adrenaline group, they were unknowingly given adrenaline. And then these individuals were further broken down into subgroups. So some of these individuals were told about side effects of their injection. So they knew that, in what's known as the informed group, they knew that there were going to be side effects and they'll feel like kind of just increased arousal due to their injection. There was then what was known as the ignorant group. These individuals were unaware of the side effects. So they were never told that there was going to be any change in how they felt. And then finally, the misinformed group, they were told of inaccurate side effects. Okay. So then later on, all these individuals were placed in the same room as an individual who was acting in either like a very happy, friendly way, what they called euphoric, or in another condition, participants were acting very angry and volatile. Okay, and what was interesting is that those who were in the ignorant and the misinformed groups, so they received this injection and they either were not told about the side effects or they were told about the wrong side effects. They were more likely to attribute their own change in physiology experienced due to the shot to be due to the person that they were sitting in the room with. Those who were in the informed group, so they were told that there would be these changes, and these were accurately told, right? They were actually more likely to understand that these changes were due to the shot, right? So again, this cognitive aspect here. They were less influenced by the participants in the room. They were less likely to mirror the Confederates' behavior. And so again, we see these changes occur. Here's a kind of almost a strange video. You'll see why here in a minute, but it's known as the Suspended Bridge Study. And this too shows the importance of cognitive labeling when it comes to our own physiological states.
A high suspension bridge on a windy day is just the place to put Art Aaron's theory to the test, that danger can provoke passion.
We had an attractive young woman stand on this scary bridge, and every time a young man would walk across by himself, she would stop him and say, "Excuse me."
I'm doing an experiment for my psychology class on the effects of exposure to scenic attractions on creative expression. Would you mind filling out this questionnaire for me, please? Here's a pen.
Almost all the men agreed to do it. After all, it was an attractive woman asking a man to do something. They didn't want to admit they were scared.
And then I have a picture for you to look at. And I'd like for you to write a brief dramatic story based on this photograph.
Okay. So the man would write the story, and when he was done, she'd say,
"Thank you. I appreciate your time. And I don't have a whole lot of time now, but I'd love to explain the experiment in more detail when I do have more time. So I'm going to give you my number, and then you can feel free to call me. It's at my hotel."
Okay. So she would write her name and phone number on the edge of her little sheet, tear it off, and hand it to her.
Great. Well, my name's Linda, so
Okay.
I hope you call me.
Okay, Linda.
Thanks.
She stopped 20 men on the scary bridge, and then she stopped another 20 men on another bridge that was a big, heavy, safe bridge, not very scary at all.
I am doing a project for my psychology class on the effects of exposure to scenic.
Of the men who met her on the scary bridge, many more phoned her that night than the ones who met her on the safe bridge. The other thing we did is we looked at the stories they wrote. Far more romantic and sexual content when they met the woman on the scary bridge.
She's embarrassed because her boyfriend wants to marry her.
Than when they met the very same woman on the safe bridge.
I think this woman is a little embarrassed about something that's really not that important at all.
Aaron believes that when our heart is pounding in our chest, we unconsciously look for the most attractive explanation. And if an attractive person of the right sex is standing by, then we're happy to assume we've fallen in love.
So the narration in that video is just absurd, but still interesting study. Again, we see this misattribution of why one's feeling the way that they're feeling, right? And so on the shaky bridge, participants were more likely to call the research assistant because they misattributed changes in their body due to, they thought it was due to attraction, where in fact it was due to the shaky bridge, right? In the stable bridge condition, people were less likely to call her as a result, right? So that kind of ties into the Schachter-Singer theory. It adds this additional wrinkle to the mix, talking about cognitions and cognitive appraisal. So let's talk about pathways of emotion. Ultimately, there are kind of different ways in which we process specifically fear. There's kind of this quick route. There's kind of this more deliberate route. I'm not going to get too much into this, but we are going to talk about this very important structure here. It's a part of the limbic system, and it's known as the amygdala. We'll talk about the amygdala more specifically in relation to SM. She is a woman who didn't have an amygdala on either side of her brain. So we'll talk about the importance of the amygdala here in a bit. We do understand, though, with emotional arousal, it's regulated by both the sympathetic and parasympathetic branches. I won't belabor this point too much since we've already reviewed this in previous chapters. But again, remember, these two branches of the autonomic nervous system have reciprocal relationships to one another. And these systems underlie emotion in part. Okay. They also are involved in our fight or flight response as well. So emotion and the brain, through EEG studies, through fMRI studies, and other neuroimaging studies, we understand that there are some different circuits in the brain. So for instance, there are some hemispheric biases. So the right hemisphere, this is kind of more involved in like more negative emotions. It's also hyperactivity in the right hemisphere is related to depression. Just the opposite in the left. So the left hemisphere is more related to happiness, being enthusiastic and energized. One of the most reliable markers of how happy a person is the degree to which we see hemispheric asymmetry in activity. So if the left is more active than the right, then the person tends to be happier. Right versus left, just the opposite. So it's pretty interesting nonetheless. So with this knowledge, there's been some really interesting therapies trying to adjust this asymmetry between the hemispheres. There's no one emotion center in the brain. Here we're looking at the brain and areas that have been implicated in processing and experiencing different emotions, such as happiness, sadness, disgust, fear, and anger. Here we're looking at the cortex. Down here, we're looking at more subcortical areas. And as you'll see, for any given emotion, it involves this distributed network in the brain. With that said, we are going to turn back, though, to an important area, which is that of the amygdala. It's very important in our experience of fear. For the longest time, it has been called the fear center of the brain. That is not appropriate, okay? For one, refer to the last slide that we just went through. But two, it's more appropriate to say that the amygdala is involved in processing just like novel or important information. And sometimes that information tends to be like fearful in nature, right? So fearful stimuli, right? So whatever you're processing, you come across a bear in the woods, like we talked about a few slides ago, it's likely that your amygdala is highly active. It's coordinating with different areas of the body, different glands to, the end result is basically the releasing of hormones to ready the body to engage in this fight or flight response. But the amygdala is very important. We definitely understand this in the importance of the amygdala whenever we look at someone who doesn't have an amygdala. So patient SM, she had a condition known as Urbach-Wietz disease, which is a neurodegenerative disease to where, again, she, I think, was born without bilateral amygdala. So here you see where amygdala should be in a healthy control. By the way, we're looking at a cross-section of the brain like this. Here we see these two little black dots. This is where SM's amygdala should be. For all intents and purposes, SM did not have a fear response. She was not really fearful of anything. For this reason, she one time went into a pet store with the researchers who were studying her, and she would be handling very dangerous snakes and different things like that. She felt no fear whatsoever. She was mugged multiple times at knife point, partly because she was getting herself into dangerous situations. She couldn't identify what a dangerous situation looked like. They took her to a haunted house one time. People are jumping out and doing all these scary things, and she didn't respond at all. And then finally, she only really experienced fear one time, and that was when basically the researchers rigged it to where she basically felt this experience as though she was suffocating. So she was basically breathing in like carbon monoxide in like a controlled environment. And only then did she actually feel fear. But for the most part, her fear response was completely absent. Cognitively, though, she could understand like what fear was kind of about. And so, for instance, whenever she was asked to draw an image of what afraid looks like, you could see that she drew like a baby with hair standing on its end, right? She was able to draw other images just fine, though. They're a little creepy, but right. Okay. And I should have said carbon dioxide, excuse me, on the last line. So 3 more slides left. Let's talk about sex differences in emotion. I'm actually going to, let's see, I'm going to skip over the slide. Yeah, I am going to skip over the slide. I did kind of main point though, there are some differences in terms of sexes and how they process emotions. So women tend to tend to be more empathetic. There are some possible social explanations for that though. So it's not, people oftentimes jump straight to biology. Generally speaking, sexes are not that different in terms of biology, in terms of how the brain works. You know, you get the exact same structures. Granted, the brain is maybe bathed in a slightly different concoction of neurotransmitters and stuff like that, and different, of course, hormones throughout the body. But nevertheless, men and women are pretty much the same in terms of cognition, brain chemistry, so on and so forth. Let's talk about emotions and the unconscious. For one thing that we tend to do is we tend to mimic other people's emotions around us. We tend to be almost like emotional chameleons, if you will. This might explain why emotions are quote unquote contagious. Another kind of interesting consideration is like mirror neurons, which we talked about before. This might be responsible for this like memeracy. Another interesting thing, facial feedback hypothesis. This states that we're more likely to feel emotions that correspond with our own facial expressions. And so this was a really clever study that was done. Participants were put into 3 conditions. Moving from left to right, there was what was known as a neutral condition, a non-Duchenne condition, and a Duchenne smile condition. So participants were to just basically hold a pencil in their mouth in a variety of ways. But unknowingly, what was essentially happening was that in this left condition, we have, again, a kind of like a neutral face. In the second condition, though, the participant's kind of smiling, right, by holding the pencil in their teeth like that. And if you're asked to hold a pencil in your teeth like such, this produces what's known as a Duchenne smile, to where you have like wrinkles around the eyes, right? So, right. And what they found is that those who were in the Duchenne smile condition reported being happier relative to baseline compared to the other 3 or the other 2 conditions. So what this suggests is that basically emotion follows behavior, right? And so this is kind of a really interesting idea. You know, if you're ever doing something and you're reluctant, you're not enjoying it. Let's say like working out, right? You don't like working out, but you begin to work out every day. The unconscious kind of works in a way to where it starts to think, right, in the back of your mind, I must be doing this because I like it. And oftentimes your attitude changes in accordance to your behavior. Similar thing here with the smile, right? So if you're smiling, unconsciously, your brain is thinking, I'm smiling, so I must be happy. And so this is kind of the interesting takeaway. You can literally affect and change your mood through your behavior. You know, if you're ever feeling down, maybe just try smiling and seeing if that actually has an effect on your behavior. Finally, we're going to talk about lying. So first of all, lay people are very, very bad at detecting lying, no better than chance. So 50-50 chance. And in fact, sometimes worse than chance. Here we see different professions and their ability to detect lying. You know, mixed law enforcement officers, academic psychologists, even federal judges perform just better than chance, so not that great. Even the best of the best, so for instance, federal officers, they're only good at detecting lying about a fourth of the time, or 3/4 of the time rather. So not super great. One way in which lie detecting has been tried to be measured is through polygraph tests, which measures autonomic nervous system activity. So for instance, how much a person is sweating, and I think heart rate, and there are other different physiological metrics. There's an issue though with polygraph tests. For one, they produce high false positive rates. And so in other words, it states that a person is lying when in fact they are not. And it is not permissible in most courts of law. So don't trust lie detectors. Don't believe Maury. Right? But yeah, so that's lying. That's all I have for you. So I know there were a lot of videos. Some of these videos were a little bit longer in length, but nevertheless, keep up the good work. Keep up with the assignments. Let me know if you have any questions over this week's lectures. Okay. All right. Take care.